Okay, class, we're on to the shaded regions portion of the notes. Let's go ahead and fill in the blanks. To find the area of a shaded region, you're going to first find the area of the entire figure. Then you're going to subtract the area of the non-shaded regions. Okay, so let's take a look at this first example right here. Looks like we have a square with a circle inside. The reason why I know it's a square is because if the diameter is 25 units going this way, the diameter is also going to be 25 units going that way. Okay, so that indicates that all the sides are 25 feet. Okay, the first thing we're going to do is find the area of the square. Okay, I'm going to label my work just so I don't get confused. Okay, area equals base times height. So that's going to be 25 times 25, which is 625 square feet. Okay, now that's the entire square. Now we're going to find the non-shaded region, okay, which is a circle. Well, that's going to be pi r squared. If the diameter is 25, then the radius would be 12.5. Okay, the 25 divided by 2. So let's plug this in. Pi times the radius squared. Okay, I'm going to go ahead and put this in my calculator and get an approximation. This is approximately 490.87 square feet. Okay, and for my final answer, okay, I'm going to take the total area of the square and I'm going to subtract out the area of the circle. So I'm finding the difference, not the sum. Okay, when I punch those numbers in the calculator, I get that the approximate area of the shaded region would be 134.13 square feet. Okay, and I'm going to go ahead and just box off that final answer. Okay, if you need to, you can pause the video, ask questions to Coach Baldwin, then resume play for example 7. All right, taking a look at this one. It looks as though we have a rectangle, okay, and a triangle. We're going to start with finding the entire area of the rectangle. Okay, and that is going to be base times height. Remember, base and height always meet perpendicular. So this is going to be 14 times 25, which is a total area of 350 square feet. Okay. The next thing we're going to find is the area of the unshaded region, which is a triangle. That's 1/2 base times height. Well, keep in mind, okay, the base and the height meet perpendicular. Well, it looks like the height is 11. The base we have to think about. Okay, but since this is a rectangle, if this side is 25, this side is 25 as well. So it looks like my height is 11, my base is 25. Let's plug in these numbers. And that's going to give me 137.5 square feet. Now, we don't have a final answer. This is the area of the entire rectangle. This is the area of the triangle. We're going to subtract the area of the triangle out of the rectangle, leaving us with the shaded region. So our final answer is 212.5 square centimeters. And I do apologize, I was using feet over here. I think because the first problem used feet. Let's fix that. Okay, and that concludes the video notes on composite figures. Thanks, guys. We're going to find the area of a regular polygon. Okay, first let's talk about what the word regular means. Okay, an example of a regular triangle is an equilateral triangle. Okay, so a regular polygon has all congruent sides and angles. Okay, so let's fill in the blank on this first set. It says that the distance from the center of a polygon to any side is called the apothem. Okay, so looking at this picture, this is an apothem. It's going from the center to any side. This is an apothem. It's going from the center to any side. Okay, now this is different from the radius. Okay, the radius of a regular polygon is the distance from the center, okay, to the vertex. We're going to be drawing those in, but you could draw the center to the vertex. I would refer to that as the radius in the picture. All right, now the formula for calculating the area of a regular polygon is 1/2 the apothem times the perimeter. Okay, and there's another formula we're going to end up using, and it's to calculate the degree measure. I'm going to have you write it down, and then I'm going to explain it later. It's 360 total degrees divided by 2 times the number of sides. Okay, so I'll put a little statement, n equals number of sides. Okay, so let's start with 2 very simple examples, and then we'll see them increase in difficulty. Okay, the first one is right here. The directions say that each polygon is a regular polygon, so we can use this formula. That means that if this side is 24.2, that side's 24.2, and that side is 24.2. Also, all the angles are the same, so it would be 60, 60, and 60, okay, to give you a total of 180. Let's go ahead and solve for the area. Okay, area equals 1/2 the apothem times the perimeter. Okay, well, the apothem in this picture is 7. It's already given to us. The perimeter, we're going to have to calculate. Okay, the perimeter is going to be 24.2 times 3 because there's 3 total sides. Okay, that's giving us 72.6. Okay, last thing to do is just plug everything into the formula. Okay, and crunch the numbers. This is going to give you a total of 254.1 square feet as my final answer. All right, and again, this one was pretty easy because the apothem was given and the side length is given. Notice over here, the apothem is given and the side length is given. Okay, so I'm going to start with my formula. Okay, the apothem is 16 in this picture. The perimeter we're going to have to calculate. Well, there's 1, 2, 3, 4, 5, 6 sides. Okay, so 6 times our 13.3 is going to give us a perimeter of 106.4. Okay, now that we know this, we can plug it in. Okay, and when we crunch the numbers, we're going to get a grand total of 851.2 square centimeters. Okay, and this will be our final answer. Again, both of these cases were easy because they gave you the apothem and they gave you a side length. Okay, the next set of examples, they give us the apothem, but they don't give us a side length. So we're going to see how to handle that situation next. Pause the video if you need